Well, good evening everyone. To those here in the room at the IAD in London and those online, thanks for joining us. I'm Andrew Grill, the Actionable Futurist, and I'm delighted to be joined in person by Chris Jones, who's manager at the Frazer-Nash Consultancy in the North East office. We're going to spend the next 45 minutes or so unpacking Chris's career, and it's a very interesting one, and explore some interesting work Frazer-Nash is doing, and we'll open the floor to any questions. And those online, if you've got any questions, just put them in the chat box. And those have questions live. It's unusual to have a live audience. Maybe raise your hand and we'll take your question. So Chris, we've spoken a couple of times since tonight to get ready for this, and I'm really excited to share your career with the room and those online. So let's unpack your career. You basically trained as an aeronautical engineer. You were researching how to autonomously land drones on the back of moving platforms. Must have been a lot of fun, but how do you make a career out of this?
So, I mean, it was a lot of fun. There's no getting away from that master's and then PhD, and the autonomous drones bit was the PhD bit, and it was an awful lot of fun. Like down in the field in Cornwall, flying drones around back in 2005, 2007.
So the drones then must have been pretty basic compared to today.
I mean, this thing was it's a conventional helicopter, so big spinny thing on top and a little tail thing at the back. A main span of about 2 meters, main rotor span, so quite a big thing, something you need to be careful of, not like the little kind of four-bladed quadcopters you see now. Yeah, exactly. So, but it was all about the kind of, my PhD was all about control systems and the latency and control systems and using them for guidance and ultimately landing on the back of a platform. So it's that technical aspect of control systems that kind of got me started in the engineering world, and that's what took me on to an engineering career beyond that.
So do you still fly drones in your spare time?
So I never have, ironically.
Really?
I have never, ever had drones or a license these days as you need it. I've never owned and operated one other than the one with the kids in the garden and that sort of stuff. I've always used computers to control them rather than myself. It's much safer.
So you have a PhD in something you know nothing about?
Yeah, not the physical. I just crash it. We had special safety pilots who were qualified and trained to do that sort of stuff. But yeah, for me it was all about the computer control of it rather than the human in the loop control of it.
So how have they evolved since 2005? And I remember almost like a toy helicopter essentially. How have they evolved to what we see today that can actually fly on their own?
So a big step forwards in things like processing power, vision systems, so all the uses you see for them nowadays, huge amounts of stuff done with vision systems, and how do we make use of different types of data coming off a platform to do lots and lots of different things. But fundamentally, you've got an improvement in the affordability. So back in 2005, I spent something like 20,000 quid buying a big platform, came from the US. Your average person can't go out and spend that kind of money on a drone. These days, a few hundred quid, you go out, spend some money, and you'd get yourself a very capable thing that's nice and stabilized. Kids can fly it, you go up in the air. But it's about that kind of reduction in cost and the kind of market demand pulling it.
So we've seen a lot of uses for drones, photography, reconnaissance. Amazon are even toying with delivering packages. What will we see next in the world of drones and autonomous flying vehicles? So
there's all sorts. There's transport solutions, the obvious next step. People doing bits and pieces in that kind of world. I think they're starting to be used for things like window cleaning.
What?
Yeah, that's
remote window cleaning.
A practical application of drone technology is big high-rise buildings. You get a drone with I assume with a hose on the side of it. Think about where my PhD supervisor went. He's still doing research in that. He spent the last 2-3 weeks out in Guatemala, air sampling above active volcanoes.
Right.
So
you'd never have a human being there.
No, you literally couldn't send someone there. But taking air samples from particular environments and being able to improve the science by putting a platform in an aerial place that you couldn't normally go. Things like that, I think we'll see more and more. But I think the transport solutions, and when kind of the Back to the Future 2 becomes a reality at long last and cars fly.
Aerial photography is another one. I actually saw a really interesting video a few months ago from Emirates. They were launching their, flying again, and they actually literally put an air stewardess on the top of the highest building in the world, and she was actually on a harness. And there was a drone that was focusing on her, sort of holding cardboard signs, and then it flies out, and it's like she was really there. There's no way you could have done that with a helicopter even, or a real shot.
Absolutely no chance. But it just get more and more interesting, more and more exciting. The use cases just continue to stack up.
So is it right you've been at Frazer-Nash your whole career?
Yeah, so I finished PhD back in 2009, joined Frazer-Nash when we were a company of just over 300 at the time, and I've never left. There's so much stuff going on. We're now 930 odd people. So we've grown and grown the last, 11 years, 11 and a half years I've been there. But there's been no reason to leave. I've always had the opportunity to do interesting things. There's a consultancy, so I've been out and worked at Rolls-Royce for 18 months on site doing some stuff. Worked up at Airbus, I've done stuff at Fujitsu, I've done stuff on site at the Ministry of Defence. I've got all over the place and done all sorts of different types of things that's kind of what the consultancy world gives you. But I've also had the career progression of growing interesting company. So I've never really had, to this point, the appetite or need to leave, I guess, those kind of reasons you tend to jump ship of progression or money or whatever it might be. I've never really had that necessity in the business.
Have there been one or two things that have been a real highlight while you've been there?
Oh, interesting question. So, yeah, there's a few things. So some stuff, I might talk about again a bit later, but some stuff we've done to help people, I think that's the word. So as a business, we do quite a lot in the defence industry, and it's mostly regulated industries, so defence, civil, nuclear, transport and the like. But when we do stuff in the kind of healthcare domain, when we're actually helping people.
Saving lives.
Yeah, exactly. It feels a bit better than working on submarines at times, because it's a different kind of...
You're helping people rather than killing people.
Yeah, well, it's defence, it's not attack. But yeah, so point taken, yeah. But yeah, it's that sort of thing where you're getting involved in solving technical problems and challenges that really benefit people in day-to-day life.
So tell me, I know why I train as an engineer, but why did you train as an engineer?
So I thought about this, thinking you might ask this question. I've got no idea. If I look back to 15, 16-year-old me, and I'm sat there thinking about, well, I like maths, I like physics, and I like computing and IT, and you go and talk to the careers advisors at school, and
engineer.
Exactly, and you're kind of like, well, yeah, you can do engineering, aren't you? And I said, well, probably. And I had a good think about it, talked to my parents, and I thought about doing maths, not just pure maths. I thought about doing engineering, and I thought about doing engineering maths. And I ended up thinking, well, actually, the physical aspect I would miss if I went down the mathematics route.
Yeah.
You don't do the stuff that engineers do. Like I sit behind a computer all day, don't get me wrong. I don't get my spanners out and my yellow jacket on or anything like that very often, but it has a practical application that was more identifiable to a 15, 16-year-old than doing more sums. I think in reality, the practical applications of mathematics probably aren't understood quite so well when you're 16. And actually, there is a whole world of that you could explore. But for me, it was the perception and concept of doing stuff, for want of a better phrase.
So we're in a room of professional engineers, experienced professional engineers, I'll say. If someone who was 14, 15 is watching this tonight or on the replay, what would you say to them about choosing a career as an engineer? Why would you take that career path, and how fruitful and enjoyable can it be?
So the first thing I'd say is, like, engineering is not engineering. Engineering is civil engineering, it's aeronautical engineering, which is what I did, it's mechanical engineering, it's electrical engineering, it's...
Don't forget electronic.
Electronic. I used to manage an EC&I group, I should know that. It's computer science to a certain degree as well. It's kind of a form and discipline of engineering. So it's kind of got more than you would conceptualise as a 14, 15-year-old of what that engineering box looks like. The spectrum is massive, the spectrum is huge, you can do all sorts in engineering. The kind of reasons why you choose it, I probably said it a minute ago, for me it's about the doing things that you see, doing things that matter. You might have only done one particular widget or washer of that building or that submarine or that aeroplane, but you've got that connection with the real world, and that's what keeps me interested and excited about engineering.
We'll probably touch on this, and I'm not an engineer, practicing engineer anymore. I'm now in sort of marketing, and I'm a futurist. But I think that engineers think in a very different way, and because we're trained to think from first principles. I've got friends that come to me saying, oh, my Wi-Fi's not working, what do I do? And so I go back to first principles. I don't always go over try turning on and off again, but I'll think about, why is it not working? And I think as I've moved through my career into more business development and management, I still have that mindset. So do you think engineers think differently, and our first principles really helps solve the big problems of the world?
Yeah, I think so. I think it's been able to strip that stuff back and been able to see, right, and true of consultancy as well, it's not the problem that's put in front of you, so it's not client says X, I've got this problem. There's a problem, they may or may not have articulated that in the right way, and they need a solution for something. And that solution is, in my world, engineering. Yes. It could be many other things. But it's that stripping it all back, understanding what the problem is, and then solving it. That's the bit that kind of the professional engineer, that's what their job and role is.
So I know you're a consultancy, but just paint a picture of what Frazer-Nash does. I know we can go to the website, but how would you describe Frazer-Nash to a graduate engineer?
So we do lots of stuff, fundamentally. So we're, as I said earlier, 930 odd people, 10 offices in the UK and 4 in Australia. We'll talk about that a little bit later, given the audience. And we kind of do the stuff you'd expect an engineering consultancy to do. So we do mechanical engineering. We've got structures, CFD groups, all that kind of that sort of stuff. We've got electrical, electronic and instrumentation groups in the business, and we've got all those kind of bits and pieces you'd expect the consultancy and engineering firm to have. But the bit where I think we differentiate ourselves is in the systems thinking space, and it's being able to kind of take a problem from beginning to end and really apply that systems methodology to it. And on the way, we use all the other bits of our business, which are slightly more specialised. So we employ psychologists and have a human factors group. We employ specific requirements engineers who go and do that stuff day in, day out, and their job is just to go and write the top level, high level requirements and interact with people to do that. We employ fire system safety groups and specialists. We employ economists, accountants who can help take business case applications and write the business case based on engineering optioneering. So you can start to get you need to do something in engineering space, but fundamentally you're going to have to write a business case at some point to justify that. So being able to blend that economics and investment decision with the engineering options aspects of it, it's that kind of stuff. So it's that blend of doing the stuff you kind of expect an engineering firm to do, maybe not as a 14, 15-year-old, as per your question, but it's doing the other stuff with it and bringing all that together into kind of, you might only have 4 or 5 people working on a particular problem, but it's been able to stick that stuff together to solve a particular problem.
So I want to focus on a couple of things that you've shared with me that Frazer-Nash are doing that are really quite revolutionary. One is around the rail industry, and you've helped the rail industry return from COVID and allow passenger and freight traffic to work together. But it's a great story because you actually use something you've done for the defence industry to work on this. So talk to me about how this came about and how you can use what you used in one discipline to help another.
Yeah, so there's the particular project in the rail industry is all about predicting delays. So it's about delays on the rail network and how can you use data and machine learning to predict the propagation and spread of delay. So you get an idea about how a network's going to respond in the event of delays. And it's really interesting work. We've won a few awards for it. But as you say, it's kind of was all born out of something for the UK Army. So probably, I should have looked this up, 3 or 4 years ago, we started a bit of work for the UK Army all about called last mile resupply. So the armed forces in the UK, forward operating base, kind of the last big base before you get to the front line, fairly straightforward and understood logistics chain to get the stuff you need to that forward operating base. The bit where it gets really tricky is then getting stuff from there to troops on the front line when they need, and crucially, when they're going to need it. So when do they need more water? When do they need more bullets? When do they need more toilet paper? Like they all apply. You've got to get that stuff to them when they need it. So we developed a bit of work for DSTL, the Defence Science and Technology Laboratory over in Portsmouth. And what that was doing was using data and machine learning to predict demands from troops and also autonomously route unmanned vehicles to make that resupply. So significant sums of money spent on the research there. Trials have gone on with partners in the US and the Department of Defense. And it's about taking some data, applying some machine learning to it, and in this instance, being able to predict when troops are going to need stuff and autonomously getting them stuff when they need it. And what all that did was build effectively an understanding of the behaviour of frontline troops. So you've got this behavioural model of how troops are using things, when they're going to need things, and you're able to train a behavioural model to do those predictions. So when I was at a meeting in Middlesbrough and met some people from the University of Hull at the Logistics Institute who happened to have a big data set of the railway industry. So they had 10 years worth of timetable data, both what was supposed to happen, what actually happened, a huge database of geospatial data, so where all the train lines are in the UK mapped out, all the timing locations, these days the gradients across the track, and this big rich data set of information. And what we did in that work for the predicting delays I mentioned there was we took the behavioural aspects of, we understand how troops need things for the front line, and we applied that same methodology and thinking to a totally different viewpoint of rail domain data. And we used it to train a model and the behaviour of how the rail network in the UK, which is just think about it as a set of connected nodes, how that responds to delays. So you train the model based on historical data in that kind of data science type world, and then you plug in what's happening right now, so your real-time delays, and from those real-time delays you can look at how the network's going to behave using that behavioural model. So a really interesting bit of work, completely different application, but massive benefits for the railway industry out of it.
So that's the rail corridors generally, but you actually then worked out, because freight trains have different dynamics to passenger trains, how does that then flow into how do we get back from COVID as we see more passengers want to travel and they don't behave the same way as freight does. How does that actually manifest it in a dynamic rail network?
So there's an interesting challenge. There's a few things in play there. It's not necessarily as simple as passengers. I mean, I live in northern England and got the train down here today. Train was nice and full, which was good to see. But we went past a few freight trains on the way, and there's this interesting mix at the moment in the market of freight and then the big decarbonisation agenda that's going on with how do we get more and more lorries off the road and more freight onto the rail sector, in concert with people and people getting back to the trains. People are using them, aren't using them at the moment, and also the reforms that are going on in the UK rail network and Great British Railways and that kind of big change that was announced in the Grant Shapps paper a few months ago. So it's a very it's a very dynamic environment at the moment for what's going on. And one of the challenges we faced with the work I just described was we trained a model, and I talked a minute ago about we had a behavioural model of the network that we trained based on what's happened. But you look at what's happening now, and behaviours are different. But the behaviours aren't the same as they were. So does that invalidate all the behaviours you've learned? How do you modify to accommodate more passengers getting back? How do you make those applications? We haven't answered that question yet. We need people to find their new normal. I hate that phrase, everyone uses it, but you know what I mean. We need the situation to stabilise so that the rail network and everything else can find the right level of balance, in my opinion.
I suppose you've got one finite asset that is the rail corridor. You're not going to automatically build more rail. No. So you've got to share that safely and economically and efficiently.
Yeah, exactly that. And there's modern methods coming along. So the ETCS, the modern digital signalling system that will hit the network at some point in the next X number of years, that will help improve the kind of capacity on the network and squeeze trains close, whatever it will end up doing there. But the safety is the key. You can't just suddenly stick 15 more services on the network because it's not safe to do so. It's a network built to operate in a certain way against certain standards.
So a lot of this and a lot of work you're doing revolves around data. So how do you get the data on this? Is it real time from GPS, or is it, say, it's historical? But how do you then train the model with real data? How do you get that data into the system?
So there's many places you can look for data. There's many types of data you can use. There's many places you can get it from, and a lot of it depends. And there's two ways you can approach it. Do you approach it from here's a load of really interesting data, what can I do with it, and what problems could I solve with this? Or do you go, well, here's a problem, what can I go and find in the data space to help me answer whatever challenge it is you're facing? And the answer normally lies somewhere in the middle. So somebody will have a problem and you've got some awareness of some stuff down here. But there's lots of open data. In the case of, I'll stick with the trains for a minute. Getting the train down today, I could look at the train line, it would tell me where my train was right now before it got to York, and then I could see that I was 11 minutes late. That's all real-time open data that the train line in this instance are making provision of to give me as the end user a bit more information about my journey. But there's all sorts of other stuff, like when you go into Google and you look at where I am on a map, you've got GPS data combining with map data, and it's telling me where I am, and most of that stuff is freely available, it's open data. The bit where it gets more interesting, where you've got, well, not more interesting, more difficult, I guess, is where you've got less structured data, where you've got written data, so you've got written words in a Word document, and you're trying to do stuff with that. How are you going to make use of that? That's a totally different type of data challenge. And it's that sort of stuff that I think that's where it's all going, I think, but there's that kind of open data that we all see and interact with, but then there's what do our customers have behind the scenes in written words, in databases of stuff that they've been collecting for the last 20 years.
So data is becoming more and more important to every business, every discipline, notwithstanding engineering. So isn't the challenge, and you said it yourself, there are all these sorts of data, the data literacy, understanding what data is and how to process data. Talk to me about how machine learning and data literacy is important to engineers now and in the future.
So we don't need all engineers to understand how to interact with data. It's an unrealistic target. Like, you're not going to get everyone to be able to sit down, write a load of Python, do some computer code, and there's some machine learning. What we need to people in industry and all engineers, I think, to realise is what can data do. They don't have to be able to see what the data is necessarily, or know where to find it, or what it is. But what we want people to be able to try and do, I think, as society, is say, well, in engineering society, here's a problem, and I think that data in this kind of world can help me solve that problem. Not going to go and do it, not going to go and suddenly interrogate a load of data and do some stuff, but being able to understand what it is and see the applications for it. That's what I'd like industry to do.
Now, when I was studying electronic engineering some years ago, back in the 90s actually, back in Adelaide, I had to learn about Laplace transforms and Fourier transforms, and sitting here I'm getting
Commiserations,
uncomfortable thinking about that, and I now tell graduate engineers I never had to use it ever again because this thing called Excel will do it for you. But you've actually gone back and talked about Laplace because you've now got a new program running at Frazer-Nash called Laplace that is actually going to upskill 500 or so engineers. Talk to me about the program and why you started and what it's going to achieve.
Yeah, so as a business, we've got, let's say, a few times, about 900 people, and of those, probably somewhere around 100 are data scientists. There's a bit of our business that do data science, modelling, that sort of stuff. It's been a very fruitful bit of our business for a little time now. It's grown very, very strong. It's the bit of the business I grew up in when I first started at Frazer-Nash. And about, earlier this year probably, so during COVID times, our board recognised the future, the power of that digital world, and stood up a program internally called Laplace, as you say. It's named by our managing director at the time.
Because Laplace is hard, is that why?
Well, so Laplace is about, so it's a transform, Laplace. I'm not going to go.
Please, no, I have sleepless nights thinking about Laplace transforms.
But it's about, fundamentally, it's about taking something simple and turning it into something complex. That's what a Laplace transform is all about. I remember there being lots of S's involved, 1 over S and all sorts of stuff.
Please stop, no.
But it's exactly that, and that's why it's got that name. It's about taking something more simple and turning it into something more complex. So, and their program is, as you say, it's an internal investment, a kind of a 7-figure internal investment in upskilling just over half of our business in the world of data science. And it's not about taking the people who already do it and sending them really deep into data science. It's about taking people who have never seen data and educating them in the lexicon and language of data and how, the sort of thing I described a minute ago. How do you do things with data and what does it look like? What are the applications for it? And then for others, taking people who can write a bit of software already, who can write code, who maybe have done a bit of C or can write some VBA in Excel. And for them, exposing them to data science methods, so getting them to learn what Python is, getting them to be able to actually pick up some data and do some coding on real data science. And yeah, it's a program running for about 12 months in the business, as you say, about 500 of our people, but it's about increasing that baseline understanding of what is data science and how can we use it for the benefit of our people. And there's 3 things I describe as success for our people internally. There's helping people do the things they already do better. So your day job is doing this at work. How could you use some data science to do that in a different, more efficient, different way? There's recognising new things that you could do that you didn't know were a thing before. So spotting new opportunities in the marketplace. And then I think the one that I'm most keen on is the people who their career direction may change for. They've never seen it before. They might have been an engineer who's been with a business for 5 years in a human factors group, or somebody that's not naturally data rich, if you like. They do a lot more of the kind of written word. And for them, it takes them on a completely different career path, where actually they've been inspired that actually I can see this stuff, I like this, I like what I've seen and done, and they've never seen it before. And that's what I'd like to achieve.
What intrigues me is this came from a top-down approach. I spend a lot of my time convincing boards they should be more digitally curious. But talk to me about why the board saw it as business changing and they decided, yes, we're going to fund this, because there's not an insignificant amount of funding to do this.
Yeah, precisely. So it was a big investment in people's time. It takes people away from doing our day jobs, because you're training, you're upskilling, they're not delivering work, solving our clients' problems. So there's always that balance of that dilemma of getting people into that world, but not impacting our delivery to our clients. So we constantly judge that balance. But it's fundamentally, it's a no regrets decision, I think was the way.
Oh, I like that.
It was phrased from our board, they're not my words. Yeah. But it's just a recognition and an awareness, because I'm putting words in their mouths, so if they're watching this, they'll probably tell me off. But for me, they can see the good stuff that's happened in the business. They can see all the good stuff that's happened in the world. And they've connected the correct set of dots there to think, well, that must be a good thing. Let's do more of that. And that's the journey that they've set the business on.
We talk about data literacy, and it's very broad. You're right, you don't need people writing Python scripts, but you need to have people understand what data can do and almost ask, why haven't we got this data? Do you think maybe that data literacy should start back at school? I heard someone say recently to me that data and AI literacy is almost as important at a school level as understanding how money works. Because if you don't understand what data can do, you're going to be left behind. So You're doing it now to all of your professional engineers. Should we start it earlier?
So, it will probably happen anyway, would be my gut feel. I've got 8-year-old, 4-year-old and a 1-year-old. 1-year-old can't do any of that, obviously. But the 8-year-old can quite happily use a low-code solution. So he's not writing lots of detailed code, but...
So you've got an 8-year-old that codes?
Yeah, well, but in a way that's appropriate, because it's the way where, like, he's got a Harry Potter wand, because he loves Harry Potter.
And he's hacked into it and changed it, right?
No, so it's designed for that. So it's a platform you buy where it's got blocks of code and you drag and drop like routines onto the iPad, and it will then, in this instance, perform different spells. But it's very accessible, and it's something that, I mean, I'm 38, we've never had anything like that. It's like I grew up with the ZX Spectrum. Like it's a very, very different world, and some of it will drop out. In his case, he's probably doing that because that's my background, so I've sent him down that path. So I think the question is, how do you get the breadth across schools, and should it be taught? I think absolutely. I mean, they have iPads in schools, they're all swiping left, right. It's terrifying at times. But I think some of it will happen naturally, but absolutely everyone should be doing it.
So the Plus program itself, how does it manifest itself? Is it online learning? Is it face-to-face? Are there exams? Have you gamified it? How's it actually working in practice?
Yeah, so we went out and established people's learning needs. So we've got a broad spectrum of people with different needs across the business. So we went out and understood what they needed, but not in a, let's spend 3 years worrying about all the intricacies, in a, what kind of things do people need? And then I went out into the kind of learning provision marketplace, spoke to quite a number of people about what options are out there. We've now got, we're under non-disclosure agreements, so I can't talk about who, but we've got 2 leading UK academia institutions who are delivering the learning for us, all in the teams, because we can't do things like this very easily. But they're delivering 2 different kind of levels of depth. It varies from like a 3-hour awareness course through to 40 hours of course over about 7 weeks. All certified, so you get certificates at the end and all the rest of it. They go through it as a cohort of people, kind of, so there's a bit of a kind of sense of team as you're going through the learning. And then not everyone learns effectively in that way. So we've also got an e-learning platform. Okay. So we've purchased kind of global supplier of that kind of stuff and tailored the set of, there's about 8,000 courses on the platform in question, but we've tailored it to about 30 or 40 that best suit what our people need to know and learn about. And they go through it self-paced, and they'll go through it bit by bit, and et cetera, et cetera.
I want to talk about innovation. So what drives engineering innovation, and how do you take an idea to a technology readiness level?
So technology readiness level, so for anyone who doesn't know what those words mean in the audience, 1 being kind of brainwave idea, 9 being the other end of the spectrum, in service, in use, and the numbers in between representing things. Traditionally quite easy to get from 1 to about 4. So that's where you've had an idea and you've proved it in theory in a laboratory or something like that. Very difficult, it's called the valley of death between 4 and 6, which is where you take it from kind of proved in principle to practical applications in the hand of an end user in some capacity. I think 6 or 7 is when the representative environment aspect kicks in. So it's doing innovation up to TRL 4, lots and lots of that sort of stuff happens. Doing it from 4 to 6, very difficult. And that's the bit where you need, for me, it's the industry perspective that becomes very important. Sometimes technology doesn't support expansion, like actually it falls down when you put it in the real world because actually the infrastructure can't support it, whatever it might be. But for me, it's about doing the innovation but getting the end buy-in from the end users as early on in that innovation process as you can, so you can kill the stuff that's never going to work and just focus on the stuff that might succeed.
So where do you go when you're trying to start innovation? How do you spark that idea? Is it client-led? Is it one of your graduates saying, hey, I've got a crazy idea? How does that manifest itself?
So the answer is people, and all of the above, probably. So it's bright people. It's people who have had the first good idea they think they've ever had in their lives. But it's about recognising where those good ideas are, and then crucially, it's about funding. So someone somewhere in the business world is going to be paying for you to do something, whether it's government putting stuff out through UKRI, Innovate UK, and the funding mechanisms that exist, whether it's internal funding because you've got an idea that you think as the business could sell. Somewhere on those lines, money is involved traditionally. Slightly different when you're kind of one, 2 person band in a shed designing some stuff. That's a slightly different example, but in business, it comes down to people and it comes down to money. Sometimes it's competitions, lots and lots of competitions all the time for show us some innovation. So yes, that's customer pull of that sort of stuff happens, but it's when the really good stuff is when someone has an idea about something to do with data, to do with something different, that actually it's recognising that and giving it the focus it needs to succeed.
So it's great to have a room full of people, and I love being around people. But talk to me about the last 20 months. How do you innovate when you can't be in the same room? And what have you learned over the last 20 or so months, and what have you adapted that you might keep doing as a result of the pandemic?
Yeah, so personal experiences of, if you're in a room of 10 people for a day, well, let's say 20 people for a day, and you're doing some kind of ideas bouncing around and you're thinking about stuff, everyone in that room will probably say 4 or 5 daft things during the day. So someone somewhere, they're going to say things that actually, that they feel a little bit, not awkward about, but things that they wouldn't necessarily think to sell. And it's quite comfortable doing it in that environment because there's lots of you there. It's quite a busy atmosphere. There's noise, all the rest of it. When you're online, you don't get that. And people...
You don't get daft ideas, or people don't feel comfortable saying daft ideas?
So both. And it's the latter that's the problem, because the one person's talking and everyone's listening when you're in an online forum. You don't get, generally, the background noise where you can say something daft to the person stood next to you and nobody else hears. You lose all that. So for me, it's about how do you create an environment in a virtual world, as we have been for the last 20 months, where people can say the kind of daft ideas, because and not because daft ideas are good ideas necessarily, but
isn't that brainstorming? You actually want all the ideas in the room, good ideas,
because daft idea over here plus daft idea over here makes absolutely unbelievable idea in the middle. Yeah, exactly. Daft squared in the middle is a band name in there somewhere, isn't it? But it's that kind of thing where you need to create the online environment where people can feel they can contribute. So it's about creating the environment for people to do that sort of stuff for me.
So how have clients adapted to this distributed world, and how will they work in a hybrid way going forward with you?
So when we went home, it was interesting because we, as a consultancy, we're quite used to working with our clients' data because it's literally what we do, and information and all the rest of it. But our clients, quite a few of them, I won't name anyone in particular, were far less to working with their own information, not sat at the desks. So we had this weird situation where in some instances we had better access to our customers' information than our customers had. And that's just the way it was. So it's a really strange situation where you went home where clients were saying, can you do this for us, which we've never done before, because actually they couldn't get in to do these things that we could do. But obviously that, over the course of a month or three, that all solved itself and everyone went home and Dell got lots of orders for laptops and the world sorted itself out. I think the biggest change I'd say in what I see is the kind of necessity from our customers for us to be with them. So if I think what I was doing before COVID hit, I was working, so I live in North Yorkshire, and I was working over in Barrow in Frazer-Nash doing some submarine stuff, and I was there kind of 2 or 3 days a fortnight and had to be on site. An example there of, some of that's security related, some of that is just client wants you on site type stuff. And that necessity of all of us having to be like under the client's watchful eye to deliver the good stuff that we do, that has gone. Like that. It's not gone, but it's probably 10, 15% of what it was. There are times when you need to be, because we just talked about the kind of water cooler innovation-y type stuff. Some of it is much better done on site, and we are getting back to doing more and more of it. But the kind of the really hard over, you must be here to be working effectively kind of angle, we see far less of that.
I'm seeing that across the board. A lot of companies that were used to that command and control, if you're not in the office, you're not working. When everyone went home, it kind of blew that apart. But are clients seeing that you can innovate and get things done, not having to be in the room? Are they're relaxing that sort of supervisory role?
Well, it's about trust, isn't it?
Yeah.
So would a client have ever jumped to that point of like, well, here you go, here's a problem, take it away, when previously we'd done everything under their watchful eye? It would have been a big jump for them. They probably would have pointed on it slowly. They said, we'll do this little bit, and they come back to us. But everyone's hand was forced. And it's been a sufficiently long period of time that you can build the trust because you just do the stuff you're going to do anyway, and you make sure you've got the right interactions, and they see the value dropping out the back end of it. And it's, you kind of by de facto creating the trust in what you do from the customer base.
So last couple of weeks have been focused on COP26, and ESG and net zero has been top of every agenda. So what role does engineering play in the net zero debate?
So we are the people who have to solve it. Like, it's all very well Boris and everyone else standing up and saying we're going to be net zero by 2050, 2030 next week probably, whatever it is. But who's actually going to go and do it? And that's the engineering community, isn't it? That's the vast bulk of how we get there is going to be engineers and equivalent doing the things we do. Because if we're going to capture carbon, someone's got to go and design the things to capture the carbon. I'll give you an example involved in the Northeast at the moment. So the Northeast Cluster, as it's now called, got its first funding call for the Phase 1 carbon capture programme in the UK. And that's a collaboration between Net Zero Teesside, so the Middlesbrough region, an equivalent name thing I've now forgotten the name of in Humberside, but the whole region, and Northern Enduring Partnership, who are sequestering the carbon under the sea in old fields underneath the North Sea, about 100 kilometres off the coast of England. But they are in there because the funding's been put up by government to create the cluster and do some stuff. And what they're effectively going to do there is build a utility network for carbon. So they're going to develop pipes and take them up to the perimeter fence of big organisations. In the Middlesbrough's case, in the Middlesbrough chemicals cluster, and there'll be a big pipe that hits the boundary fence of the polluters. And what goes in that pipe, you've then got to get out of whatever is going on, in this instance in Teesside and Humberside. So who's going to solve that problem? Who's going to go and get the carbon when you're making ammonia, when you're making ethylene, when you're making X, Y, and Z? Someone somewhere, engineers, have got to develop the technology to capture it, to stick it in that pipe. And the infrastructure will then take it offshore. But that pipework itself, who's going to build a 100-kilometre pipe out into the middle of the North Sea? That's going to be engineers. So we are the people who are going to have to develop the methods, the technology, and all the rest of it to deliver that net carbon. Going hand in hand with that is kind of behaviours. So I got on the train today to come down here. I didn't drive. That's because we're coming into London predominantly, but I wouldn't traditionally drive anyway. But we need to modify people's behaviours and get them out of the dirty diesels into electric cars. And there's an equal part to be played there. But you look at the big emitters and the carbon challenges, it's not someone popping to the shops for 2 minutes in their unleaded tiny 1 litre Fiesta. It's the big industrial processes, and they're the big ticket items, if you like.
So what initiatives are Frazer-Nash doing to move towards net zero?
So we've got some stuff internally. So we've signed up to the Science-Based Targets Initiative. So a couple of thousand organisations around the world there targeting the 1.5 and putting it in practical terms, what you do and what you're delivering against meeting the Paris Agreement, etc. So as a business, we've stood up and said, we're going to do these things. We also do a huge amount on behalf of our customers. So we've won, I don't think it's public domain yet, but won a few.
Well, it is now.
Well, so I'm not going to tell what we've won, but yeah, we've won some big contracts, like multi-million-pound contracts with central government, looking at being their technology innovators in the carbon environment. I think it was announced about 3 or 4 weeks ago, so we're probably at the standstill period, but to play it safe, I won't mention exactly what it is. And it's things like that where we're taking our customers on that same journey. We're using our expertise to solve the problems that we've just described. Sometimes for central government and innovating in that kind of space and delivering technical solutions. Other times on a very small scale for someone with a particular widget that they actually want to make a bit greener.
So given this is an Engineering Australia event, I've got to, and I'm Australian and most of the people in the room are Australian, I've got to look at the Australian connection. We'll look at what Frazer-Nash is doing in Australia. I understand you've been heavily involved in UK submarine projects. This must be an interesting topic at the moment, given the AUKUS announcement in September. Yeah,
it's quite political as well, so I'll be a little bit careful how we talk about it.
You're going to read a prepared statement?
No. I did ask some of my Australian colleagues before this in case this came up. But so, yeah, as you say, as a business, we're about 25% of our business is submarine related, predominantly and exclusively really in the UK, with a little bit of foreign national, not Australia. But yeah, predominantly UK based. So on the back of that, we've got an awful lot of people who've got an awful lot of experience in the submarine world. And we've got another 25% of our business, which is civil nuclear, and an awful lot of experience in the civil nuclear world. So lots and lots of people who understand nuclear stuff, to put it in that bracket. We opened our first office, I asked the question yesterday, it's on the 17th of May 2010, our first Australian office in Adelaide.
We've got hometown, glad you opened there, yeah.
It's over a decade ago now. We've got 4 offices out there now, Adelaide, Sydney, Melbourne and Canberra, where we're based. And as we kind of grew, so first kind of boots on the ground was a guy from the UK, because he understood Frazer-Nash's business, a guy called Phil Harris. And he started to grow our Australian business. He's now back in the UK, still working for Frazer-Nash in our Bristol office. But as a result, we've had a number of people who've gone out to Australia from our UK business, because it's a beautiful place to be. Why would you not do that? Kind of have to say that. But yeah, it's a really, and the appetite for that has never been difficult. So we've ended up with about something like 100 man-years of experience in the nuclear world, from people who've done all that stuff in the UK who are now embedded in our Australian business. So the AUKUS deal going through, we've got people in Australia who understand and know that stuff. As a business, we employ something like 50 to 60 ex-submariners. Oh, really? So we've got a lot of ex-personnel, the operator side, which is crucial when you try to understand what's going on. And we've got this nice pocket of people with a bit of experience on the ground, an awful lot of experience in the UK, but crucially for us, we've got the ability for local knowledge in Australia with the reach back to the UK. It's all very well saying, oh yeah, we've got reach back into the UK. We could pull on some of our company's expertise from the United Kingdom, but actually the time difference is never, it doesn't work like that. You can't realistically, you're not going to deliver stuff in that kind of fashion. You've got to have the local presence. So we think it's an exciting time for us because we've got that on the ground presence and experience, plus the kind of big horsepower engine of submarine knowledge in the UK. I think the last thing I'd add is You look at what Australia are doing, kind of, we're doing bits and pieces out there in the nuclear world already. So how you dispose of nuclear medicines and what the federal government are doing in Australia for that sort of stuff involved in that kind of world. And most of the stuff that we've got experience of locally in Australia is about early in the life cycle, which is where AUKUS is right now. So it's how do you instantiate the right kind of protocols and regulation for having a nuclear submarine fleet, regardless of what platform it looks like. How do you understand how to write a safety case for having propulsion devices powered from a nuclear reactor? How do you understand? And those kind of early stage bits of the nuclear cycle, we've got an awful lot of experience in Australia being able to do. And that's where we kind of see the opportunity for us, and it's an exciting time for my Australian colleagues with that sort of stuff. Yeah.
So in each of our Spring Forward series, this is the third one, I've asked our guests about how they see the notion of returning to first principles when solving complex business problems. Mm-hmm. Give me an example of how you've solved a problem going back to first principles.
So I had to think about it. So Andrew warned me this question, and I had to think about what I've done that I thought you had to strip it back to the bare bones of the problem the most. And it's a healthcare example. So as I said earlier, I might revisit it. I knew I was probably going to revisit it. And it was about helping people with dementia. So something that we did in probably 7 or 8 years ago now. And there's a real problem with when people have dementia with keeping them hydrated, because the degeneration, they forget to drink water. And it's not deliberate, it's not conscious, it's one of those things that happens. And as they get dehydrated, their symptoms exacerbate in other areas, and it kind of spirals and it gets worse and worse. So the challenge, it was an innovation challenge, this one, how do you help in that environment? And the answer is, well, you need to drink more water. But for me, the interesting bit about that was, because we were talking about people who have dementia, everything you think about being the right solutions probably isn't the most effective way of solving that problem. Yeah. So you go all the way back, and what we did, we stripped that right back to, what is the fundamental problem we're faced with? How do we interact with someone who isn't necessarily thinking as we would think, through no fault of their own, and how do we help them to do the thing they need to do, which is to drink more water? So we developed some prototype devices. We went into care homes and sat down with people who were suffering from dementia, tried some stuff out with them in a fairly controlled environment, as you'd imagine, and developed them, two products span out of that at the back end, 2 bits of innovation. A very simple coaster that kind of did some stuff that triggered alerts, and a more sophisticated kind of jug system that alerted carers to what was going on and the rest of it. But the bit that I found fascinating about all that was just the lack of ability to rely on what you thought was the right solution, and actually having to pay it back to the first principles of, this is the problem, but this is the problem as the problem is seen by others, not the problem as seen by you. Yeah. It was a really rewarding bit of work.
Love that. Mm-hmm. So I want to find out a bit more about you before we close. We know you've got 3 kids. One is a Harry Potter coding geek. Yeah. So I'm going to run you through a quick fire round.
Okay.
iPhone or Android?
Android.
PC or Mac?
PC.
Biggest hope for 2022?
Ooh, more live sport. Watching more live sport.
Okay. The app you use most on your phone?
Oh, this from the last one, Sky Sports. Yeah, Sky Sports, absolutely.
The one thing you won't do again post-pandemic?
Commute as much.
Okay.
Yep.
What are you reading at the moment?
The moment is The Timeless Swing by Tom Watson. It's not helping my golf at all, but that is the current bit. That is the book by the bed at the moment.
And final quick fire round question: how do you want to be remembered?
So I think balanced. So I think I'm in a leadership role at Frazer-Nash. I have a young family, as we just described. I think the way I'd like to be remembered is career successful, but not at the expense of family life, which I'm sure is what everyone aspires to. Yeah. But I think, getting that balance right COVID has made that significantly easier, and I want that to continue.
So as I'm the Actionable Futurist, I want to know 3 actionable things that our audience should do today when it comes to data literacy and innovation.
So I'll start with, I'll do 2 on data and 1 on innovation. Mm-hmm. So data, I'd encourage everyone to go and watch a TED Talk. Watch a 10-minute, half-hour, 1-hour program on what is data. You don't need to understand it about the intricacy of what data is, but just understand what data is about, and crucially, what data exists around you and what people do with it. We all see the stuff about Facebook and everything else, and just become a bit more self-aware about what data is, what it means, and what people do with it. I think that's the first thing I'd say. I think the other thing I'd say is don't be afraid to have a go with data. So we talked about the low-code world a minute ago, where if you're going to have a play around with some data, you can go online, you can do this kind of drag and drop thing. So you rather than writing a for loop to do a load of stuff and iterate over some data, you can literally, as described by my 8-year-old, drag blocks of code in that do pre-described things. It's really easy to access. Just go and have a play. Like, just find something online, find something in the library, whatever it might be, but just go and have a play with some data. It's accessible, it's easy, and it's what all the kids and youngsters are growing up doing these days. So be part of that world would be the other thing I'd say. And the third thing, innovation. So I think innovation, I'd say, be an extrovert when you might not feel like one. So plenty of our best ideas in life and society come from people who don't have the loudest voice. They almost certainly don't have the loudest voice in a room. So if you're going to be involved in a piece of innovation, make sure that you are heard. It doesn't have to be you standing up at the front of a room and screaming and shouting about something. Just make sure you've got your methods to go out there and get your bit of understanding, idea, whatever it might be, understood by the people who matter. And that's what I think. That's
Three very actionable ideas. Thank you for that. So, final question: how can people find out more about you and your work?
So I'll be in the bar in a minute. So that's
for those online that can't come to the bar. How do people find out more about your work?
Come and have a word. Everyone online. My details I can share. Probably if you send a link around, reach out to Frazer-Nash in general. www.fnc.co.uk. My email is c.g.jones@fnc.co.uk. Ask Andrew. Ask James, the Institute of Engineers Australia. They can put you in touch. Best way of learning a bit more about Frazer-Nash is pick up the phone and have a conversation. For those in Australia, anyone watching, I can put you in touch with my Australian colleagues, probably more relevant than talking to me here in the UK. For anyone in the UK, you come to me, as I said, there's hundreds and hundreds of us. There'll almost certainly be an interesting conversation to be had.
And a plug for you, you're hiring at the moment. Who do you need? What sort of people do you need?
So all of the people, I think, is the answer.
Okay, can we be more specific? What sort of roles do you have at the moment?
So obviously all the kind of data and other worlds, big hot skills in nuclear industry at the moment. Kind of finding nuclear qualified people to do stuff very difficult. But you look at our career section, we've got 50, 60 job ads out at the moment for safety engineers. There'll be human factors people, there'll be data people, there'll be modelling people. Our grad scheme is currently open. Applications for that close in December time. We had something like 2,000 applicants for that last year. Took on 30, 40, 50 people last year in the graduate scheme. But yeah, it's anything that I've talked about as I've gone through today, we are almost certainly recruiting for. We've been growing. I said earlier, in the 11 years I've been here, we've gone from 300 to over 900, all through, not through acquisition, it's all just through growth of employing people and doing more and more interesting, exciting things. But yeah, the one thing I say we don't do, I guess, is we don't do a lot of civils stuff. So that's not a part of the industry we've ever really operated in. So if you're a civil engineer watching and want to know more, Frazer-Nash isn't necessarily the right home for you. Any other type of engineering, get in touch.
But other engineering organisations are also available.
Yeah, correct, exactly that.
Thank you so much for your time. We have some time for questions before we go to the bar here in situ. And if you're online, you can go to your own bar. Is anyone in the room, first of all, have a question, a burning question I'd like to ask Chris? You have a question? If you just ask it, I will then re-ask it so the people online can hear as well.
Okay. All to do with artificial intelligence. You talked about machine learning and artificial intelligence. I'd like to get your thoughts on where you think it's really headed. I've read quite a bit about it.
Yep.
Some of it scares the absolute daylights out of me. So, and I know the scientific community is kind of split halfway. Some think it's going to be the nirvana, others think it's going to be Armageddon. So where do you and where do your colleagues sit on the next 50 years and the way artificial intelligence might get us?
Okay.
I'll just replay that for those online. So the question was basically to do with AI. It's scary. Are we headed for Armageddon or something else? What does the next sort of 50 years look like for AI?
Okay, so I'll give you the perspective from my perspective rather than Frazer-Nash's perspective. It's probably a safer thing to do.
Asterisk.
Yeah, exactly. Yeah. All the kind of caveats around it. So you look at what AI is, you look at what machine learning is, and there's a common, not misconception, but people kind of bucket them together as the same thing. So machine learning is about taking data and spotting trends in it and using computers to spot trends in data to make predictions about what's going to happen. And fundamentally, that's what machine learning is. There's many ways you can do that, and it's a whole field, there's a whole career to be made in machine learning. AI is about how, and there is no universally agreed definition of AI, really. There's lots of people who talk about AI means this, AI means that, but no one's really agreed what it means. But fundamentally, it's machines, computers making decisions for themselves that could result in them flying me in my autonomous car somewhere nice and safely could result in them blowing up the world. And that's the Armageddon factor, as you describe. For me personally, the bit that interests me, and there's a whole bit of our business has been stood up to look at this specifically, it's around the safety of AI. So as I mentioned earlier, we work a lot in regulated industries. I'm talking about my personal view and now talking about Frazer-Nash, but yeah, we'll ignore that. There's a lot of stuff we do in regulated industries. You're not going to suddenly go and deploy a load of AI when that world emerges properly to go and do safety critical activities. You go and deploy them into a regime where you can control the boundaries of what they do. So you might start off, the way I describe it is, you've got a process that sits in the middle where the computer's doing something for you. And it might be the autopilot on an aeroplane. Everyone's fairly comfortable with an Airbus, Boeing, doing some of that stuff for you these days. But when they started it, they didn't just go bananas. You compartmentalise and box up. And then slowly, as you gain trust in it, your kind of safety box, if you like, that you've put around it to control it starts to grow. And you allow it more and more autonomy, more and more control in what it can do as your confidence as the human in the loop there grows. And that's what is happening with Tesla. Look at what they're up to in that particular domain at the moment. They started with, we all started with a bit of kind of cruise control where, well, yeah, I'm quite happy with this. The car's driving itself at 70 miles an hour and I'm happy with that. And then all of a sudden you've got like, oh, now it's warning me that it's straying out of this lane. And at first you're a bit like, I'm not sure about that. But then you're like, oh yeah, I can deal with that. And you're building that boundary of the box up. So the Armageddon moment, as you describe it, comes when either the stuff inside breaks through that box, because it's got enough self-awareness and we're in the Terminator world that it can smash down the barriers that we as society have put in place, or we relax it to a degree where it could escape, if you like, where we take the boundaries away. Somehow it's got to get outside of that trust remit. On a personal level, I'm not worried about it. I don't see the Armageddon stuff happening, like the modern civilized society, and in the same way we have automated control for a nuclear reactor, we don't just let it loose to do what it wants to do. We have things in place, we have safety cases that are inspected and approved by the ONR, the Office of Nuclear Regulation, and it's all very well bounded and restricted. I think the same thing is bound to happen with AI. The danger with all of that stuff, from nuclear through to everything else, is the rogue actor. It's the person who deliberately intervenes to cause the problem. And the fear factor arises when the autonomy is that self-aware kind of terrified element of it, when that might break through, and that's where people get scared. But I'm not overly worried that in my lifetime or in my kids' lifetime. I don't think it is, and if I'm wrong, it doesn't really matter because we'll all be gone anyway, won't we? So yeah, it's fine.
But from a futurist point of view, one thing we need to be worried about now before Armageddon is the ethics of AI. Yeah, correct. Because when you deploy an AI system, you have to have humans to teach it, and so there's always conscious bias that's taught into that. So the big issue at the moment, and a lot of the big tech firms are starting to look at ethics around that, is who's programming it. So probably in the future, we're talking about AI literacy. Do you know who's actually programmed the cruise control? Yeah, correct. There's the whole trolley scenario where a runaway trolley is running down the road and it's either going to hit a young couple with a baby or an old couple. Who do you kill? I don't want to ever have to make that decision, but the ethics in that is who's actually going to be spared. So the thing today, before we worry about systems mutating and taking over the world, is who has programmed your system. If you buy a box of cornflakes, it says what the ingredients are, and now you're legally required to talk about the different colours and all those sort of things. I think we may get to a point where AI systems have to come with a health warning. This has been programmed by someone who has far-right tendencies, so beware. Another question in the room before we go to some online questions, yes?
Yeah, so with complex systems and never-ending data sets, how do you manage things like analysis paralysis? You know, you can optimize something until the cows come home, but how do you actually feed the practical and human touch into it? So
you want to repeat the question for our friends online?
Go on, I'll let you do it.
No, you can do it.
Okay, so the question was, how do you build in the kind of realism, the practical element of big data into analysis paralysis, as you phrased it there? So the answer is understanding your data. So if you look at solving a problem with data, and this is something that most people don't necessarily self-recognize. You've got a problem to solve and you've got some data that you're going to use to solve it. In solving that problem, you're probably going to spend 85% of your time working on the data. And at the last bit, the last 15-20% of the time, it's probably going to be the nice glossy looking front end where you've then got the things you want out of it, and that's the nice bit that answers the question at the back end, or the front end, quite literally. And it's all about understanding the data. So the role of a data scientist, the role of someone to understand how to do things with that data is in the difficult processing, amalgamation, reformatting, structuring from unstructured data of the data set. And if you do that well, it might take you a long time. Might not be, it all depends on what you're looking at and what kind of scale, big data, small data, whatever it might be. But you focus in on doing that, and you try and prevent yourself from getting just completely bogged down in analysing every single bit of data you've got. To kind of put that in a real world example, you think about the world of digital twins is a hot topic these days. So there's a million definitions of digital twin. The true definition in my mind is when you've got a real engineering thing. So we'll take one that pre-exists. So civil aviation, Rolls-Royce engine health monitoring system that sits on one of their civil aerospace gas turbines, transmitting data back to a synthetic version of that, where they can monitor and predict the health of the thing that's in the air using a model and prediction of something that's on the ground using real-time data. That stuff doesn't get born instantly, and actually it'd be very easy to say, well, we're measuring the stage 4 gas turbine temperature 58,000 times a second because that's what our onboard control systems need. Why don't we transmit all that back to the systems that are digital twin on the ground? And it's almost certainly not the right answer. The bits of data you care about in that digital twin environment are probably the temperature once every X, because you've got a reduced order model running on the ground. You don't care so much about all of the detailed measurement. So it's about, in that instance, it's about big data from lots and lots and lots and lots of sensors. But which bits do you actually need, and which bits do you need to do some edge processing on plant, wherever it might be? What do you transmit back? And it's that data engineering phase of the life cycle to stop yourself ever getting overwhelmed by, well, I'm going to run a simulation for 5 days now because that's what I need to do. Sometimes that's appropriate. Most of the time, often it's not. Have I answered your question though? Yeah, okay.
Time for a couple more questions before we go and have a drink or do whatever we do online. Julie asks online, your Laplace program sounds interesting. What's been the hardest part of rolling this out?
So people finding time for me. So it's an exciting thing, and the business are excited about it. People want to do it because it's a new skill. It's a good thing to do, and it's an interesting thing that people hear about. But fitting it in around everything else that one has to do at work, when you're talking about, well, I've got 6 weeks for you to go talk to this university about learning about this stuff, and it's going to take you about 8-9 hours every week. Is that all right? And they've got a customer over here saying, do this, do this. They've got 3 different bits of business development going on over here. They've got to go to events like tonight, things like this. Finding that right balance of the enthusiasm from people and fostering that enthusiasm in all of our people so that when they do it, they have time to do it, they're engaged in it, and they're doing it to the best of their ability and getting the most out of the program. That's the bit I worry about most. Yeah. It's not necessarily the most challenging, but it's the bit that I worry most about getting right.
One more question in the room before we break.
You talked early on about the military defence and the requirements of, say, soldiers, and also logistics in trains and transport. Recently we've had issues of people factor, of panic buying. I'm thinking, to in particular of fuel, but also torque paper or, say, straight bog roll. How does that, can you model that, or can you sort of predict or explain, or obviously models can work through those issues?
Yeah, so just want to repeat the question.
Oh, yeah, go on. So I keep forgetting to do that. The question was, how do you account and plan and predict human behaviour? So the answer, in the situation of panic buying fuel we've had here in the UK, in the situation of toilet roll, bog roll, panic buying at the early days of COVID in the UK, can you predict those kind of behaviours and can you do something about it? Is that a fair summation? Yeah. So the answer is yes and no. So in my summer, I'll give you an example. So in my summers, when I was doing my undergraduate degree, I worked at Bristol Airport because I'm an aeronautical engineer, so watching the plane lands all day.
You're an airplane geek.
Yeah, I absolutely loved it. I was sat in the old air traffic control tower and just watched planes land all day and decided where they'd park when they landed on the airport and ordered them new fuel.
Stop now.
It was unbelievable. But in that role, one of the first things they taught me when I rocked up at the airport and I had to do the training was, as soon as people walk into an airport, perfectly sensible, normal people turn into idiots. And it's the prediction, and it's true, you walk at an airport and you see people doing really stupid stuff that they wouldn't do in the normal world, but they think it's appropriate to go and shout in someone's face when they've missed their aeroplane. Like, behaviours change, and predicting how people respond to that, which is the kind of the essence of your question, is hard. So there are psychologists, there's behavioural people, and as I said earlier, we have a human factors team who do bits and pieces in that world. I'm not an expert in that world, but it's understanding the core nature of the problem. So could we have predicted a year and a half ago that toilet, or bog roll, put it in Australian, is going to be a problem? Possibly, because you're going back to that, what are the human deepest needs and urges? What do you latch on to? And then it takes 15, 20 people to do something. In the case of the fuel crisis, it was a leaked memo report from one particular person at one particular organisation, and the panic sets in. It's difficult to model the when, I think, because that's tricky. That you wouldn't have predicted that in the petrol instance there, that situation was going to be on that Tuesday because Fred went and blabbed to the Daily Mail one after the other. You're going to struggle to do that kind of thing, but understanding and predicting the consequence of it. So, right, we've now got a shortage of commodity X. How do we solve that? That is stuff that we could stack up. And engineering does that. You look at, I'll talk about civil nuclear again, you look at the safety case for a nuclear reactor, you don't go and inspect it all the time. You inspect it once in a while and you find some stuff when you go and inspect it. You need to have the right things in place, the right bits of a safety case to cover the things that you're going to go and potentially discover. So that when you do discover them, you go onto the bookshelf, you pick out the right book that covers that particular scenario, and you can continue to operate. I think as society, and Bill Gates is talking about this lots, isn't he, about that post-COVID pandemic task force of let's understand what happens, let's model and predict what happens. Predicting when you trigger that is the difficult bit for me. Predicting how the supply chain of bog roll would have behaved, I think you could do that. You could do that now, couldn't you? It's just a logistics chain of like any other good. It's the fact that nobody had understood that that was what was going to be needed, and that's how we do it. So yeah, hard to predict the when, not so hard to predict the consequence of that thing happening, I think is the way I'd answer your question.
Chris, thank you so much. I've learned a lot tonight. It's fantastic to have you in the room and share your experience and your insights. I know this is very unusual, but let's thank Chris in a very non-pandemic way.